I'm sorry to interrupt your regular programming, but we have just received some breaking news here at Wolfpack WTVD regarding fire-resistant seed adaptations. Wildfires continue to devastate millions of acres of land annually, leaving a dusty ash trail behind. The increasing frequency of wildfires globally have left scientists questioning what the long-term effects of this destruction will be in terms of the environment. While wildfires leave countless individuals homeless and confused every year, it seems as if certain legume seed species have adapted to thrive in these fiery conditions. My name is Jeremy Shaw, and I am here with my colleagues Sydney Seiter and Miranda Sharpe to break the news on how certain legume species have overcome all obstacles to flourish in an environment that has been ravaged by wildfires. In the past, scientific literature has shown that elevated temperatures and other fire cues do play a role in breaking of seed dormancy and initiation of germination in certain hard-coated seeds. Therefore, the question raised is whether or not this fire-related germination affects all legume species or if it's merely just a regional phenomenon. The first segment of the breaking news, we will travel to the southern Brazilian subtropical grasslands. Here, Alessandra Fidelis and her team set out to investigate the effects of increased fire temperatures on the efficiency of seed germination in 6 different Fabaceae legume species. These seeds were subjected to dry heat shock temperatures at 60, 90, 120, and 150 degrees Celsius. They were then grown in the germination chamber for a period of 60 days to monitor germination rates. The results of the study did not indicate that the elevated fire temperatures increased germination rates, except for in 2 of the legume species tested. On the other hand, since the extreme 120 and 150 degree temperatures did not decrease germination rates in any of the legume species, the authors concluded that these legume species have adapted to be fire resistant. Now I'll send you to Miranda Sharpe to see what she has to say about the subject.
Thank you, Jeremy. Fire-resistant seed adaptations have been a big topic of discussion since brush fires are becoming increasingly more common. The effect on seed germination of legumes and other common species found in wildfire-likely brush is linked to heat range of the fire and chemical constitutes of charred wood and smoke. Not only does fire temperature influence germinated seeds, the smoke and soil composition post-burn greatly affect the success of seed germination. Bernard E. Overbeck, Sandra C. Mueller, Valerie D. Pero, and George Pinford have done a study about how seed germination in fire-prone ecosystems is stimulated by heat and how seed size affects germination rate. Most of the species tested showed that germination percent is higher in heat-treated seeds, which shows that these seeds have adapted to a wildfire environment. The study also showed how the seed depth in the soil has more to do with germination success than the seed size. This is because heat from fires decreases as you go deeper in the soil, and the chemical constitutes from the smoke do not permeate to a certain depth in the soil depending on the soil type. Now I'm going to send you to Sydney to talk more about these wildfire effects.
Thanks, Miranda and Jeremy. Fire is a pertinent topic in today's news. In addition to research presented by my colleagues, I would like to focus everyone's attention on 2 Acacia species. An invasive alien species of Europe, Acacia longifolia and Acacia mirandsi, were the subject of research published in 2020 by Riviero et al. Their paper was focused on the effect of fire conditions on germination of the seeds of these species. It was found in this study that the ash, smoke, and char from burnt remains of A. longifolia and A. mirandsi did not have a significant effect on the viability, dormancy length, or germination of seeds of these species. The temperature was the main conditional factor, which caused a difference. Fresh seeds of A. longifolia lasted faster with heat bursts, germinated faster with heat bursts. Both mature A. longifolia and fresh and mature A. mirandsi seeds germinated quicker with heat bursts. Heat bursts over 150 degrees Celsius killed the seeds of these species. As you can see, the topic of fire in relation to germination of seeds is a robust topic full of ongoing research. For our conceptual question, I would like to ask, in wildfire conditions, which factors seem to have the most effect on seed germination? Temperature, smoke, or char or ash? The answer is temperature. Thanks for tuning in and learning about this extremely relevant aspect of our ecosystem.